Okay, guys, I did this. I thought I did this lesson, and I didn't yet, so it's a little bit out of order. This is basic derivative rule. So the derivative of a constant of any number is 0. So remember, derivative is slope, you guys. So think of a line like y equals 7. Well, the slope is 0 with the line y equals 7. It's a horizontal line, okay? So the derivative of any constant number is 0. The derivative of any polynomial with a power right here is just this power comes out in front right here, and then we just decrease the power by 1. So say that was x to the 7th, then this would be 7x to the 6th, okay? So it will be decreased by 1. All right, and then trig, the derivative of sine is just cosine, and the derivative of cosine is opposite sine. All right, so let's try some of these, you guys. So remember the old way? This old way, if we had y equals x squared, then the slope of the tangent, which is derivative, you guys, would be we'd go the limit as c approaches x of x squared minus c squared all over x minus c, because I'm just following this rule right here, and then this is the difference of squares, becomes x plus c, x minus c, those cancel. So we have x plus c, and then we substitute in c equals x, and we get x plus x, which is just 2x right there. Okay, and this is a simple one, you guys. You saw how they got complicated the other ways. Well, look what happens with the power rule, you guys. The power rule just says if we with y equals x squared, this 2 just comes out in front, becomes, and then decrease it by 1, so it's 2x to the 1, which is just 2x. Okay, same thing. Much quicker using the power rule. All right, so find the derivative of each function. Okay, so y equals 7, I kind of gave away that. These are all constant, you guys. These are all numbers. They don't have any x's with them, so it's just the constant rule is that they're all zeros right there. Okay, so the derivative of any constant is always that they're just equal to 0. All right, so let's do these ones here. So I just slid that up there, you guys. I think I already did that one for you. So the derivative of this would be this 7 comes out in front, becomes 7x, and you decrease it by 1, 7x to the 6th. Okay, this negative 4 comes out in front, so it becomes negative 4x, and when you decrease it by 1, it becomes to the negative 5, so negative 4x to the negative 5. This 3 comes out in front, multiplies with the 5, becomes 15x, and decrease squared, 15x squared, okay? Nice and easy, you guys. There's 7x to the 6th, negative 4x to the 5th, and there's 15x squared. So the derivatives are, just bring that down, okay? So here, when you see this, negative 5 root x, you can treat that root x as x to the 1/2 power, so it's negative 5x to the 1/2. So this 1/2 comes out and multiplies with the negative 5, becomes negative 5 halves, and then decrease it by 1, 1/2 minus 1 is negative a half, okay? So then let's clean it up. So negative exponents will go down to the bottom and become a positive exponent, so it's negative 5 over that 2 right there. That 2 comes down there, x to the positive 1/2. All right, so and then they put that back in radical form. And in calculus, you guys can have the radicals in the denominators. They teach you in Algebra 2 and a little bit of pre-calc to rationalize the denominators and get rid of them, but in calculus, we don't have time to deal with that, so we start dealing with the numbers we plug in there in just a little bit, you'll see. All right, so the derivative of this, okay, so here I'm going to bring this 3 out in front because now it becomes 3x squared, and then the derivative of cosine is opposite sine, so it's going to change that to a plus 3 sine, okay? So 3x squared plus 3 sine x. How's that? Pretty cool, huh? Okay, this one here. All right, what I would do on this one, you guys, is go ahead and cube the 2, make it an 8, and then so this is going to be 5 over 8x to the third. All right, and then I'm going to change that to 5/8 x to the negative 3, and then this negative 3 comes out and multiplies with the 5/8 and becomes negative 15/8. Decrease it by 1, so it becomes negative 4. You guys with me? So negative 15/8 x to the negative 4. Now I probably should have put that x in the denominator, and it probably should have been negative 15 over 8x to the positive 4, but either one's okay. Okay, all right, this one here, you guys, I think the best way is to FOIL that out, x plus 3 times x plus 3. Okay, you get x squared plus 6x plus 9, and then take the derivative of this. The derivative of this 2 comes out in front and decreases, 2x to the 1, which is just 2x. And this, there's an imaginary 1 right there, so 1 comes out and multiplies, and it becomes x to the 0. Anything to the 0 is 1, so it's just 6. Okay, pretty groovy. All right, so if you're in my class, that would be your homework assignment.